The next problem states that a fluid with internal heat generation flows through a pipe with a constant and uniform wall temperature. And then they ask us to derive the energy balance to describe the temperature profile in the axial direction, and we cannot neglect axial diffusion. So let's start by first highlighting all of the components within this problem. We have internal heat generation, which is an input of heat within the boundary. We have the fluid flow through the pipe, which will result in a change of enthalpy over the system. We have a pipe with a constant and uniform wall temperature, which will result in a convective flow over the boundary of the system. And then it is also mentioned that we cannot neglect axial diffusion. So knowing all of this, we can write down the energy balance. On the left side of the energy balance, I'm going to write all of the changes in energies that are occurring. So there will be a change in enthalpy, and there will also be diffusion. And then this will all be equal to the heat added to the system minus the work done by the system, but there is no work in this case. So we will just take into account the convective heat transfer and the internal heat generation. And now we can define all of these components. The convective heat transfer will be based on Newton's law of cooling. And Tm here refers to the mean temperature within the pipe. And then finally, the internal heat generation.